Going on, guys. In this video I have some problem from linear algebra, um, matrices, and it's going to be about linear equations, right? So I'm going to solve these two questions right here. The first question is I'm going to do the 15th question. Given the linear system, 2x minus y equal 5 and 4x minus 2y is equal to t, and the first question is asking determine a particular value of t so that the system is consistent. So first of all, we have to know what is consistent mean. So I'm going to show you. So consistent mean a line that is coincident with the another line. You may ask, what is coincident? Coincident means one line that another line, like one line is here, and if another line overlap this line and go this way, it's called coincident. So for example, in this equation, how can we make coincident? To make the coincident, the multiplication of any value of the first equation should be, say, that whatever the equation we get should be the multiplication of the another equation. So in order to get that one, if you see the first equation, it says 2x minus 5 equal 5, and if you see the second equation is 4x minus 2y, so it means it's multiplied by twice. So in order to get the coincident line, we have to get this one multiplied by 2 because then only it will be both will be a same equation and the line will be overlap with each other, right? So therefore the t should be 10. So only if the t is 10, then it would be a uh, consistent. And the second question is asking determine a particular value of t so that the system is uh, inconsistent. So first of all, we found what is consistent mean. Consistent mean whatever the value uh, that that will give the coincident. So inconsistent mean whatever the value that will not give. So in this case, uh, this will be only coincident when it's 10. Otherwise it will like overlap with each other or like whatever happened, right? So not overlap, like cross with each other. Sometimes it may go parallel or something like that. So whatever the value except the coincidence is going to be inconsistent. Therefore whatever the value except 10, so t is not equal to 10, whatever the value without 10, it's going to be inconsistent. So the third question is asking how many different values of t can be selected in part as b. So it's infinitely many. Except 10, you can choose any number. So infinitely many solution this system has. So that is the answer for this question. The next question is 70. Given the linear system x plus 2y is equal to 10 and 3x plus 6 plus ty is equal to 30, the first question is asking determine a particular value of t so that the system has infinitely many solutions. So as we said already, if the system has to have infinitely many solutions, the first equation and the multiplication of whatever the equation has to be similar. Uh, then only the system will have infinitely many solutions. So in order to get the similar multiplication of this value, we have to see the values first. So first is 3x and second one is 6 plus ty and third is 30. So if you see, it's multiplied by 3, and we have to, in order to get the infinitely many solution, we have to multiply this one by 3 and this already multiplied by 3. So if I multiply 2 by 3, it's 6. So 6 plus t should be zeros, then only it will give 6y. So if I get 6y, it's infinitely many solutions. So the answer is t is equal to 0. And the B question is asking determine a particular value of t so that the system has a unique solution. So unique solution mean whatever the value uh, except 0 is going to give you unique solution, because if you have 6, it's like 0, it's going to be infinitely many solutions. So whatever the value except that's going to give you a unique solution. For in case you can take 5, you can take 1, you can take 2. So whatever the value except 0 is going to give you a unique solution. So how many different values of t can be selected in part B. So it's infinitely many. You can choose any number and it will give you your unique solution except 0. I hope you guys enjoy this video. Have fun, have a good weekend. See you later.